Hi, and welcome everyone to this episode of Breakpoint. The topic for today is IoT security, safeguarding your smart world. The world is getting smarter, and the number of IoT devices is growing by the day. Securing such environments presents unique set of challenges due to the diverse nature of these devices and the complex set of interactions between them. To discuss this relevant topic, today we have none other than Aseem Jakhar. He's the co-founder and director of research at Payatu. He's also the founder of Null, the largest open security community of India. He is also the co-founder for Nullcon, Hardware.io, and Payatu, and also the creator of EXPLIoT. He's also spoken at various international conferences, including Black Hat and Defcon. Hi, I'm Neelu, a technical security enthusiast and your host. I welcome you to the Breakpoint Security Podcast. In this podcast, we'll explore the depths of defensive security. We learn the methods and techniques that the smart security teams are using to solve practical security challenges today and innovate their way into the future. Welcome to Breakpoint, Aseem.
Thank you so much, Neelu. Pleasure to be here.
So IoT and IoT security, I think this is, when we talk about IoT, yours is the first name that we can always think of. So I thought, why not get Aseem for this? And we'll have tons of questions today. So hope that will not bug you. Just for the audience who are not familiar with IoT security, one of the things with IoT is we've been hearing about IoT, smart homes, smart devices, smart cities for quite a long time now. I think quite a few years now. And I was looking at some of the stats. According to stats, we have billions of such devices today. In fact, close to 20 billion connected devices around the world, and that number is only growing. And when you talk about IoT, just as an IT market, it is close to $600 billion. We know that there is a lot of work going on. We know that there is a lot of research happening in this area. And that means only more and more product and more such complex devices and environments coming up. How do you see this as a problem statement from a security perspective overall, Aseem? You think it's the size is something that we can tackle today, or?
So let's start first with defining IoT, because otherwise market research firms are great at creating new jargons for different things. So for me, I take IoT as any connected device that can bridge between the physical world and the virtual world. So and translate data from either side. So for example, a camera which captures the physical world and pushes the data onto the cloud, or a smart lock which controls the physical world to lock a system. So anything that is capable of doing that, I would consider that as IoT. And then comes different terms like industrial IoT, cyber physical systems, Internet of Everything, and so on and so forth. So you can't help that. Anyways, so with the context set, now let me ask you this question. Since you are the pioneer in software security, tell me what is the impact or the maximum impact that can happen, let's say, if a software gets compromised. It can be anything. It can be, on your cloud, it can be a web application, mobile application, anything limited to software. So just think of very quickly, like a rapid fire, think of the repercussions or the impacts that can happen.
Yeah, I think generally, if you think of it quickly, you will have financial loss. You may have the business transactions failing, financial loss to those companies, also reputational loss, personal data that can be stolen, and data leakage and things like that.
Great. Yeah. So personal data leakage, very bad for people. Financial loss, it can go to millions and billions. Now, let's come back to the IoT world. So IoT is not only this, which we just discussed, financial loss, data leakage, breach, whatever, state actors, and whatever you can think of around software breaches, right? That, and plus the most important aspect, which is physical damage, which means loss to life, right?
Hmm.
And this aspect in itself is so scary that when we look at devices, you really one of the things that I keep telling is that we really don't need James Bond style exploits for these devices, right?
Hmm.
As long as I can shut that device down, any device that is doing a critical operation, if I can shut it down or if I can make it malfunction, I think
Hmm.
my job as a bad guy is done.
Hmm.
Think
Hmm.
of hospitals, think of power plants, nuclear power plants, think of cars, right? So, so the impact is hugely or greatly different from when you look at only software-based systems, and that's where it started. My interest in these things started because I looked at it and I looked at the impact, and the technology is so complex, so complex. Like, we're not talking one system here. We are talking hardware, we are talking firmware, we are talking radio interfaces, we are talking cloud security, we're talking web, we are talking mobile. So all of
Hmm.
this
Hmm.
combined makes a tiny thing, as tiny as a smart toothbrush or a smart watch, right? So, so complexity wise, it's very complex, and from security perspective, we're just starting.
Yeah, so I think I could not help but avoid the visualization that was coming to my mind when you're talking about what happens for these physical systems, right? Which could easily be just shut down. And I was embarrassingly thinking of the Bangalore traffic, and if you had an autopilot car and suddenly everything was shut down in between all the traffic, what would happen? But I think that is still a trivial outcome of such an attack. There are bigger outcomes, as I totally understand. While you're talking about complexity of these devices, right, I was also thinking of, like, from general security team that may be helping organizations who are in the IoT domain secure that, or even attack that, because we do that through both attacking and securing those. The complexity is high in this case, and one of the reasons why the complexity is high is that there is such a diversity of these devices, right? They may be from different the components may be from different OEMs, different manufacturers, which contribute it to the final place of assembly, where again these IoT products are eventually assembled with all of these different components, and then some from these organizations as well that are creating these products for us. And that involves a lot of unique software, firmware, different kind of security features which may not be enabled for these firmwares and all of that forms the final product. And that is what leads to a lot of complexity. Particularly, I'm coming from the firmware standpoint. Now, if you are an organization that is creating this end device or product, how would you go about managing security for such ecosystems?
All right. Yeah. So very interesting question, and to the point, I must say, because this is one of the core problem statements for at least as far as connected devices go, because every component will have its own software or firmware, as you whatever you want to call it. And then you would have certain components that software components that you would buy from other things. So when you're creating a final product, how do you keep track of this? So one of the things now, what is happening is on the compliance and regulation side, where governments have also come up with regulations, and there are also alliances formed, domain-specific alliances, as well as security standards. So what happens is, if there is like a tiny chip that has a use case specific for automotive, for example, it will still fall through the automotive cybersecurity standard. So the car manufacturer at the end, for example, Tesla or Maruti, or I don't know, will have to follow these standards. But it's not just the car manufacturers; it's also the component manufacturers who have to follow. And this is uh, uh, quite common in some of the domains, but not so common in some of the domains. But the good thing is that the standards are almost here now. We have different standards. The other problem that we are seeing from a use case or a perspective when we speak to some of our customers who use our products is some of the large organizations. What they're doing is when they're procuring devices from vendors, which will go into their infrastructure, be it whatever cameras or fingerprint machine, whatever it is, they have a red team specifically to do security assessments of these devices, and then based on the vulnerabilities identified, they will either go ahead with the vendor, inform the vendor of the issues, or reject the vendor at all. Uh, so not only are the vendors looking at the security of this, but even the enterprises who are taking the products from these vendors interested in at least doing one round of security assessment. And the problem persists because there were no standards earlier which would govern the security, where the vendor can come and say, hey, I am under this regulation, you can see I've got certified. So at every chain, people are doing their job. It's just that it was domain specific till now. For example, medical. In medical, you have high security standards because you need to meet FDA requirements. In consumer tech, it was like, man, I'm just making a camera, right? What happens if my camera or my smart lock doesn't work?
Who cares? Yeah.
Yeah, who cares? So people started finding vulnerabilities around these devices, and then they started demonstrating the impact depending on how these devices are placed, right? A smart camera at home may not be a very, very critical device, obviously, yeah, critical for the family who owns it, but versus a smart camera deployed in a bank at a locker room, right? So the use case of the devices will also use to govern how what is the impact of vulnerabilities, which is now changing for good for us as well, because now we can easily sell our services and products. But I think it was needed.
Yeah, I think don't want to slip in this one, but I think this compliance actually drives a lot of this in all the domains, not just IoT. And yeah, that's something that as a technical security person, as an individual, you realize much later, I think, how much of a role compliance and regulations and standards have to play in driving some of this. But that's one side of the things. Like, for example, if you are trying to configure things securely, follow certain standards, guidelines when you are working with these devices. But the other side is, okay, now you have done all of that, you followed these standards and done this. And then comes the part where you're maintaining these. And many times I have seen, having, worked for some of these other organizations, IoT organizations also, that many times the firmwares are not updated. And that is the reason, not necessarily because the custom code was, there was some line of code that was an issue, but in general, they've not been upgraded or updated. They're not kept maintained over a period of time, which are the low-hanging fruits from an attacker's perspective. So
Yes.
When you think about, the answer to this is patching, maybe. And patching is, as simple as it may sound, can be very complex for this kind of an environment. I think we have had multiple guests on the show, and we are talk to them about DevSecOps and patching and all. But when you think of the landscape and attack surface in IoT, it seems like way more complex. How would you recommend solving that with respect to the firmware?
Okay. So
Patching and things. Yeah.
So legacy devices, if you look at it, they have a process of manual updates. Things like printers, those conference room phones and all, where you can manually update. And then there are some devices which do not have any updates at all. Like startups will build, and then they will wait for this thing being accepted. Over time, either they will die or something else will happen, and there will be no updates. And then there is automatic updates. Automatic updates are more recent because of the push from regulation. So for devices within your infrastructure where there is no parent in the sense a company that owns uh, the product itself. Uh, I think you are at a high risk as an organization. You are at a high risk because they're never going to be updated. There's absolutely no way in which you can update them because they are every device is a completely black box for you as an organization, right? When you look at different devices, TVs, cameras, you don't have an access to those devices, right? So you absolutely there is no way for you to patch those devices unless those devices are some of the legacy devices which have a manual way of updating them. Like you download the firmware from the vendor's website, go to their web panel, upload the firmware, and then it gets uploaded. So from that perspective, I think there are startups who are trying to solve this, scan the infrastructure for these devices, and try and auto update on these devices. But so this update comes at at one stage ahead, but the first thing that you need to identify within your infrastructure is, do you really know how many devices do you have in your infrastructure? And I bet if you ask this question to CISOs, at least in our region, they will not have an answer for it. And
Yeah,
so,
I mean, we never had an answer for, I think for maybe genuine reasons as well, but how many applications we have, and then we did not have an answer how many APIs we had, right? So this problem, I'm sure, extends to the IoT landscape as well.
yeah, and you can't blame them because there is absolutely no tooling that can help you do that till that date, and there are a bunch of startups which have not reached these companies yet. And there are traditional companies that can identify machines on your network, but they still can't identify these new devices on the network. They can obviously give you an IP address, but they really can't say that this is a thermostat or this is a camera or this is a phone or this is something else. What about things which are running on different radio interfaces and not Wi-Fi?
Okay. So for a large scale environment where you have maybe thousands of such devices or nodes, as maybe we can call it, you would need a mix of, as of what is the current progress today, you'll need a mix of both the manual updates maybe and automated updates wherever possible, and then go from there. Am I correct?
Yeah. One thing is forcing the vendors, like the red teams that I mentioned you, who are responsible for doing security updates, security assessment. Companies can ask for direct questions in terms of what is your update cycle, what is your end of life cycle, to basically understand whether they are going to do automatic updates or not. So if you ask these direct questions, you will get direct answers, yes or no.
Yeah, I mean, you should expect that as well. So
yeah.
So I jumped to firmware because I was very curious about it. But in general, while you're talking about this attack surface, a lot of things are, getting revealed. I think overall, when you must have addressed a lot of these problem statements for organizations already, and you've also created EXPLIoT, the framework itself. But I wanted to actually touch upon some of the basic aspects quickly, like in terms of the process. What is the process that you either follow or recommend organizations when they are building? For example, let's take a simple case, an IoT product rather than an entire product suite. What is it, where is it that they can start off? One is the standards, but does the process look like at a high level? Like what can they do one after the other? If the security teams or engineering teams are listening to us, how can they go about it?
So we borrowed from software security a lot because that's what we knew before we entered into this market. So there are some things that we typically do is look at the maturity of the organization, and based on that we suggest how do we go about. I think ideally the first way is to know where you stand. So you do an assessment for the product, and then that gives you a clear idea of where you stand in terms of cybersecurity. And then based on the results, we look at where we should put more focus from a design or a development perspective, and whether there are some things which are actually possible to do or not. Because if you identify something on the hardware, it may not be monetarily possible to change the hardware design, based on whatever costing or maths the vendor does. So those are some of the things that you need to look at, and then you start imbibing those, or shift left, or if there's any other jargon for that, you go to the designing stage, be part of the development team, and start looking at how we can push some of the things from the testing perspective back to development and design. Can we do CI/CD for the firmware scans? Can we do CI/CD for something else? And if there is a hardware change, then discuss with the hardware designing team in terms of how can we fix any of the issues that are already there. Can we fix it in the firmware, or do we need to fix it in the hardware, and so on and so forth? And then goes ahead. Then you need to follow standards. You need to do a lot of other things, which is where there are a lot of guidelines now for specifically IoT. Uh, OWASP is still not mature enough, I would say. So if you're looking at IoT security, don't only look at OWASP. Look at other things. So there is an organization called IoT Security Foundation based in the UK. It has come up with the guidelines and has a checklist. It can become a standard as well, but uh, it's not. It's more set of guidelines, but it gives you a very, very clear perspective of what exactly you have to look at from your within your product to be able to build something that has baseline plus products that will go into critical sector to look at security.
Hmm. I think, yeah, that simplifies this a lot, especially for people who are, currently doing bits and pieces, but have not, or the teams that have not been able to put the entire thing in a straightforward manner, one-to-one, So how does one thing lead to another, and then how they can eventually start moving towards a more mature ecosystem. You were talking about hardware, and I was thinking hardware is, I think, one of the unique aspects what makes actually IoT different from our usual software. Going back to our first question of the damage. Now, when we talk about hardware, in the past few years, we have been listening about a lot of incidents that are reported or not reported, where malicious or compromised components were added to IoT devices with or without the visibility of the final product manufacturer. And that happened during the manufacturing process itself. So, for example, the chips and some other components where there could be compromised components which has been added to this overall. So this, I think, relates to the point of overall the supply chain side of things when it comes to an organization that is, like we were talking about, taking all of these components from different places where they may not have visibility into their own security processes of these respective manufacturers. So how do you in general look into the space of supply chain security today for when it comes to the hardware and hardware component side of things?
Okay, so again, this is a difficult problem to solve. There are certain startups who have products in terms of looking at certain things, whether for example, the end product, is it exactly the same as the hardware design that was given to the vendor to create the final hardware. Uh, Other than that, then there are things like, as I mentioned, like common security practices. Let's take simple example, right? We use Bluetooth in our daily lives everywhere. Bluetooth is everywhere.
Yeah, yeah.
And let's say vendor XCOM is has 50% market share in Bluetooth chips, right? And so it is deployed in phones, speakers, wherever, TVs, whatever, in hospitals. And suddenly some researcher comes up and says, hey, I found two critical vulnerabilities in chips from XCOM, right? And now what happens is, and these vulnerabilities have good impact, like they can shut down or do whatever remote code execution or whatever is possible. That's the assumption. Now, what do the vendors do? If that vulnerability cannot be fixed from the firmware side, so all these vendors are now at the mercy of XCOM, right?
Yeah,
And
to
XCOM
fix
says
that.
we can't fix it in the firmware.
Okay.
What does so think of that scenario now. What can these vendors do? There's nothing that they can do, right? Other than recalling the product back. So, so this is where the difference between IoT or a hardware security plays from the perspective of software. If it can be changed from software, uh, that can be done like within days or maybe a month if they are, or 2 months. But if it's a hardware problem, then it just cannot be absolutely changed. And there have been, not just in IoT, there have been a lot of hardware specific vulnerabilities that have been found in Intel chips, AMD chips as well. So there is no clear answer to that. Right? When it can't be fixed from the hardware, you have to recall. If it can be fixed in the software, then you at least have you can force the vendor or the end component supplier to be able to at least give you an update for the firmware which you can push to your products.
Are there any I think I was looking at so doing anything, trying to do anything will take time in this case, right? I mean, even if you had replacements, generally you may not have, which will work with the rest of your system. Even getting those replaced, that will also take time, but it's not practical. Firmware is one solution, and the other that we generally have for other things in the industry, similar things, is the regulations. Do regulations help with these kind of issues, or do we have these new clauses added? Like these are the timelines within which the hardware manufacturer will have to address the issue in some way?
I don't think there are any specific regulations for this. They would, I think, broadly fall under same software as well. But there's no foundation in terms of the timelines, I think.
Okay.
At least I have not seen. At least I have not seen this.
Yeah. Okay. So, but with hardware, I was also thinking of the problem statement overall. I was thinking apart from these kind of compromised components, right, which is generally a little more high profile because they obviously affect maybe millions of devices in some cases. There's also the issue of physical tampering, side channel attacks, so generally, what is your opinion to how to tackle these issues to prevent any kind of, for example, data exposure through these issues and things?
Yeah. So this is, I think, again, part of the security assessment process where you look at different aspects from, compromise in terms of the end product, or identifying ways security vulnerabilities within the hardware that could lead to whatever control, data breach, whatever. So there are certain things that the end manufacturer has to obviously do at their end, because given, let's say they're using a microcontroller which says, oh, we do 128-bit AES encryption, right, and we are compliant to FIPS, blah 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 blah. And when it comes to the developers, what they do is they use it and they say, okay, we are going to secure user data, or we are going to secure the firmware, we're going to use AES 128-bit encryption and whatnot, and then store the key unencrypted on an external flash chip, right? So even though the chip manufacturer has good security standards, the developers might not follow or might not understand the repercussion of storing the keys. So these are some of the things that you can then identify at least at the security testing stage, that your developers are at least following best or security best practices. Not keeping debug ports open if they are not required. One of the very common things is debug ports. Like you will typically find application debug ports on the hardware, or microcontroller debug ports, which are basically game over for any device. And so these are some things or checks that you need to do at the security testing side, and then try, once you've done it, as I mentioned, then you can start shifting that left towards the development to say, hey, make sure that when you compile your firmware, these ports should be closed if they can be from the firmware side. But then there are certain times when there are use case where they cannot because of a contract with a third party who does the support, and they require access to these ports when a device comes in for maintenance or so on and so forth. But those are essentially the entry points.
Yeah, there is so much not in our control. I think we definitely should, as security teams, can try or at least strive to achieve as much as we can. I think testing gives a very good visibility, like you mentioned, and I can correlate from that perspective that at least the ones that we can control, we can definitely go ahead and make changes about, those issues. While we were talking about interfaces, I was reminded of some of the sessions. So those were the days, like I think quite a few years ago, when we used to try everything that was there. And thanks to Null, that you co-founded, basically, there were some of the sessions where I was, and we were just trying to, those days it was new, IoT security was pretty new, we we're just hearing about it. And there were 1 or 2 workshops that I was, also trying, let's see how it is. And even those days when we started with the actual, or we were to get into actual exploitation, we would take the help of these interfaces that you're talking about, UART or JTAG, the debug ports and things like that. So while we are on that topic, how as a security team today, when I'm thinking about it, what is it? So I was curious about, one is the attack side of it, but mostly how do we go about securing or ensuring that these interfaces are secured? And work around it.
All right. So securing is again the same testing as well as DevOps perspective. But again, when we started, we had the same problem, and this is what makes security assessment for an IoT product extremely challenging and difficult, right? You will have one day one device with a Bluetooth interface, another day one device with Zigbee interface, another day with some other interface, and then you will have the PCB board which is running, okay, which has open, let's say JTAG port or SWB port. But when you run, so you need to customize some of the software. You run it, doesn't work, you try something else, then it works, and then you note it down, okay, yeah, I have a custom script for this, then, and you keep doing it over time. So basically, one of the patterns that I saw was that uh, researchers and security teams were wasting a lot of time in terms of customizing communication, at least for these interfaces, let alone, and then go to the meat of the assessment where they will try different payloads. And so that was primarily the point when we thought of creating this framework, EXPLIoT framework. And the idea was simple, that if you have basically what would make my life easy, right? Given any kind of different device, if I can use the same software to be able to run my payloads through any popular interface, let's say. Right?
Okay.
So I don't have to customize every time whenever I have a new device. Obviously, when I have a specific use case, then I can extend and write a small plugin utilizing the actual core interface protocol, and just write the payload that I want to send, or do whatever kind of communication. Think of like Metasploit, right? That was
that's
the
what I was
inspiration, right?
thinking about. Yeah.
And so that's when we started creating this framework, and I think it does a pretty good job in terms of the diversity of interfaces that people can access through the framework itself. For example, for software, it does MQTT, it does COAP, it does Modbus. On radio side, it does Bluetooth, it does Zigbee. On hardware side, it does UART, it does CAN bus, it does JTAG, SWB, and a lot of different things. So you really do not need to scratch your head when you have a device. You know that there is a plugin available in the framework which you can use. Now, one of the thing is you're saving time. The second thing is not only that, now you can automate your testing as well. So whenever there is a firmware update on the device, you have a test suite, a regression test suite, or a security test suite. Just fire, click, go ahead and run all these tests. Right. So that makes life easier, and that was the primary goal which we for creating this particular framework, to be able to save a lot of time for people, and I think it's doing its job pretty well.
Yeah, these are quite a few interfaces. I think I was initially, when you were talking about this, right, and that the new interfaces keep coming up, and then I was just thinking from, because by default, from the attacker's perspective, that now I have to figure it out. I mean, theoretically it is easy to say, but practically you have to figure out how to work with all of these interfaces, and then only understanding everything you go beyond with the actual payloads and how you can improve on the payloads. And there are a lot of steps to that, and multiply that with the number of interfaces that are there. That can mean a lot of work both for attackers and also for the defenders in the industry. So this is a great framework that you have put together. I hope this is open source, right? And
yes.
So I hope a lot of us actually can go play out with the whole thing, and then also contribute to it. I think this is something that I've seen, especially from a security side of things, both attack and defense side. The open source contribution is an area that we need to improve on and build on top of what is there.
Yes, exactly.
And remembering the Metasploit, the Metasploit days, right? I think it makes the job much easier, because all of us who have done this manually, and even in the case of IoT or otherwise, when you do an exploitation manually, it's way more work than what was solved. So whether it is EXPLIoT or Metasploit, these kind of frameworks, they solve for the most part, and then you only need to invest on your intellect on the actual exploit. So
yeah.
Okay. So that brings us, coming back to the actually IoT devices. There is one crucial aspect. So we generally talk about, I was thinking of the server controls and other components, and then I was thinking of the overall architecture that IoT has today. How does the attack surface look like? But when I was thinking of it in the current day context, things suddenly changed for me, because like you were saying, right, when you look at IoT devices, it's very different from other kind of software. Because think of it, an IoT device is either on your hands, like for example as a watch, basically having your maybe blood pressure, your in case of manufacturing, can be temperature and pressure of some places, which is highly sensitive information, based on which a lot of critical decisions are being taken in the entire IoT ecosystem. So it may have even data like not just your BP and your blood sugar, but also the nights you did not sleep, and a lot of different patterns, health patterns which are there. In actual healthcare, it can have way more sensitive information, right? And stents also, these days you will have these devices. In SCADA systems, and in so many other kind of ecosystems, you have this, of course, in cars and all of that. And in every places, including places like home automation, right? When you have these, any information that is essentially going through these devices or using these devices is highly sensitive, especially from a personal perspective, but also depending on the system and manufacturing, it can be from a different perspective, but it is sensitive by default. So when we think of software, a chatting software or some other kind of software, we could be dealing with a lot of static information, but only in case of IoT, for sure, you will be dealing with something which is sensitive and helps in some kind of decision making down the line. And this kind of sensitive information is not just from a data security perspective, but from a privacy perspective also plays a major role. So from that perspective, how do we go about ensuring the secure transmission, but also storage to prevent, because in this case, if you have unauthorized access to this kind of data, that can be damaging to a big degree. There can be real-time impact, like we were just touching upon initially. So how do you look at privacy? There is data security, but privacy, I thought, was a little more challenging to do from an organizational perspective. What is your take on that?
So essentially, I think for us, and I believe many other companies, privacy has always been part of our security assessments. So we look at when the data is stored, what information is stored, and if it's not encrypted, is can there be any impact of if this data is stolen? Does it have personal data and so on and so forth? So, but and this is not just since you mentioned some of the devices. Uh, let's say tomorrow your there is a connected device you use in your home for whatever purpose, a small device, maybe um, $20, $50 device, and you've been using it for 2 years, doesn't work anymore. What do? You throw it in the dustbin, right?
Hmm.
Yeah. So do you know how much information that device still has on you? And the simplest and the uh, most, I would call, yeah, the simplest information and the easiest to and one which has the most impact are your Wi-Fi credentials. They're still on
Ah,
the
of
device,
course.
right?
Yeah. Hmm.
So and that's just that any device will have. Then based on the use case, it will have different data on you. And for especially for startups, since there were no guidelines or standards, they can do anything because when it comes to hardware, everyone trusted hardware, right? When there was a boom in oh, hardware is so cheap, we have Raspberry Pi, we have Arduino, we have this, let's make prototypes, right? And then once they make prototypes, let's make the product with this only.
Right.
And then they'll go ahead and sell it. And if there is some customer who pokes around and finds, he will publish it, and then they will go about thinking of how do you go about securing it. So one of the things that at least enterprises started doing was pushing the same standards, right? Because for us, for them, it's a black box that they cannot peek in the hardware. So if I'm a European company, you comply with GDPR, right? And so that solved at least part of the problem, where they are still at least regulated from an existing standard perspective. So even if now they're doing privacy, they don't have to. They're not doing only on the cloud or the mobile, but they have to do at the device as well.
Yeah, yeah. But when it comes to, for example, I think GDPR has taken care of a lot of things for the European demography, but in general, I think I was also looking into the standards. Standard also taking care of some of the domains, like you mentioned, like healthcare and this and that. But when it comes to personal information for individual users, are there also some standards that you need to or can align with, or there are none at present for individual personal information?
Now there are. I think all major regulations now cover privacy as part of the standard itself. IoT. I'm only talking about IoT.
Okay. Yeah, I think that because I was also reading somewhere that these particularly these PII is captured by a lot of these companion apps, right? Like your health apps and things like that. And there was a research done for I also linked the research. It's quite interesting. There are, I think, 6,000 odd companion apps, and one third of those, one third, which is a big number, were actually having data exposure issues, which was identified in the research still. So imagine the entire space, right? Problem space could have way more than that. Okay. Cool. So there is an interesting development that happened recently, which I wanted to bring up and also know what your opinion is on that, because you have helped a ton of different organizations in this space. And it is called the US Cyber Trust Mark. You might have heard of it already. I got to know, of course, recently. The announcement happened in July, this July itself, 2023. And it was around security labeling of the smart devices or the IoT devices. And they're basically focusing on the smart consumer products. So now the announcement basically mandates that there should be security labeling on these the smart consumer products, and it has to show the level of security of the IoT products.
Yeah.
So the question was slightly different than technical. First of all, on a capability side, do you think that the industry, the IoT industry, is prepared for it? Because there are a lot of moving pieces involved, a lot of dependencies like that we have already talked about in the previous questions.
Yeah.
Is it even possible? And what do you think is the way forward if that is?
Yeah. So if it were to be done today, or let's say by year end, then we would have 100% non-compliance.
Okay.
So it is absolutely difficult to follow a regulation when you've not been through any, and bypassing your way to the consumers. So, and this is just the recent, right? So US comes up with something that becomes like a gold standard. So US has come up with it now. It's still not enforced. Whereas I think there is another, the initiator for labeling scheme was Singapore. They have a program called
Oh,
Cybersecurity Labeling Scheme, which
okay.
defines levels. And I think they have a mutual understanding, or an MOA with Germany and I think Finland as well, in terms of the acceptance of this. So anybody gets this CLS can sell to Germany as well. And then US has come up in July. So I think the way it is going to happen is probably it will start as a self compliance, where you can do a self compliance and get a certification lab to certify or whatever, and then sell the product, because that's an easier way for acceptance of a standard. I don't know the details because I couldn't find much details on the US cyber trust mark, like how are they going to enroll or roll this out. But typically it happens like this. There are other standards as well, like CE, and if you pick up any device at your home, you will see things like FCC, CE, ROHS. All those are certifications, and I think uh, some of them are self-compliance as well, where you can certify and you can say we follow these standards, to be able to make it easy for uh, companies to do and then sell their products out. So there has to be a timeline in terms of when they're going to be like strictly become mandatory. But if you ask me, I think for devices where the use case is going to be on a critical side, I think that has to be uh, uh, implemented very strictly. For example, medical, uh, uh, like FDA is already pretty strict with terms of cybersecurity. There might be loopholes, but at least they have stringent process in terms of what the vendor needs to do to comply to FDA rules. On the industrial side, there is a standard, but whether the devices are going to go in a nuclear power plant or just a small SME kind of an environment, or a small factory environment, the rules need to be stringent for something that is going into a power plant. Right? So those things, if they happen, I think then people will catch on.
Yeah, yeah. It was good to know that Singapore already has that. I think these are some good examples to follow. And now that we already have our data protection bill and things that have already been set up for that, I think we should also look forward to hopefully having a standard of our own for this as well
Yeah,
in
we
terms
have
of
our own
IoT.
standard. We have our own
Okay.
standard, which is in the works. BIS, yeah, I'm part of the
Hmm.
BIS panel as well. So there is a standard that we are creating in India.
Okay,
That's for
great.
security, IoT security and privacy, and it goes ahead to an evaluation perspective as well. Like how would you evaluate an IoT product from a security perspective, and then based on labeling as well.
Oh, that's great.
So we have
That's
our
really
own.
good
Yeah,
to
it's
know.
coming up. It is coming up.
Okay, that's nice. Cool. Thanks a lot, Aseem, for joining us at Breakpoint today and answering so many of these questions and clarifying this space a lot for all these, security teams and in fact also engineering teams who are working in this domain on how they can go about securing their environments.
Thank you so much, Neelu. I mean, it was a pleasure, and it was really interesting to vent out my anger as well, like from a security perspective. But yeah, it's really good. Thank you.
Cool. Thanks everyone for joining us today. We'll see you in the next episode. Until then, bye-bye. Hey folks, that's all we had for today. I hope you enjoyed this one. Visit the podcast page for more such interesting episodes. You will find the speaker suggestions and other details in the show notes below. If you're interested in a security challenge of your own or would like to hear from a specific speaker or team, let me know in the comments below. Lastly, if you liked the episode, please go ahead, give it a thumbs up, subscribe, and share with others in the community. It always means a lot when you do that. We'll see you in the next episode. Until then, Breakpoint signing off.